We'll continue with our module 5, and here we'll be looking into chamfers, the dress up features chamfer or applied feature chamfers. And chamfers are one of the straightforward, very simple operations where the angle and distance are only involved. There is no lot of complicated parameters involved here. So it is very much straightforward. So the mode you can select by length or angle or distance, etc. So how to do that? That will be looking here. So for understanding this, we'll be looking at the model, this one, and this is the output. Okay. So if you look at this chamfer, what you need to do is you just select the object to chamfer, this edge, and here you have specified the distance and angle. And here you have bunch of other options, length and length, only distance, etc. So let me apply to this edge so that you can understand this clearly. So what do you get? Chamfer. Here you can see the chamfer and choose the option. Here are the 4 different options, length and angle. And my length requirement is 15. And after setting the 15, I want the angle as 45. And you can see the preview. And you can go to reverse also. This side could be 15 and that side could be angle, and you can reverse it. So when this is 45, of course, both will be same. But if you go for 60, the distance will be different. So why the error message is coming? Because there is no material. Okay. So what you can do is this 20, you can make it 40 so that you can really see what is the effect of that. So select this and go to 60, and this could be 15 as per our specification, and see the preview. Now you can see this is the 15 and 60, and if you reverse this, the side will be flipped, and here you can see corner cap, and this corner cap I will explain what is the meaning of corner cap. So if you have multiple edges, okay, for example, this all, let me delete it, and I'll go for a chamfer and select all these 4 edges and go for corner caps. So in this case, you can see the corners, and you can reverse that directions as well. You can go to the more and chamfer corners setback. Here also you can apply the distance like your fillet. Let us say I need to give a setback for a particular surface. I can show you that also. Let us say we have one reference plane from here in the reverse direction. It could be somewhere inside 40. Okay, so here. So go to the chamfer, select the edge. I'll be okay with 10, and 45 angle will be okay for me. I'll go to the more, chamfer corners and setback. If you see this preview directly, this the whole edge is selected. And now if you try to apply this chamfer at a particular corner, and once you go for this particular setback, let us say the setback I'm interested to have at 25, and see the preview. Okay, what happened is it is starting from here and it is ending. So the plane requirement, like your fillet or any other operation, is not required because we are directly driving through one point. So if you go to this selections also, here the setbacks for all other side like 10, 10 and 25 also can be edited here, or you can directly edit from here, maybe 30 for that side, maybe 25 for this side, and you can see the preview and go to OK. So these three different corners are attached and a single chamfer definition connecting all will be set. So here the chamfer corners are important and the plane concept is irrelevant. So it is very important to understand this concept by using the setback options. Let us look at the other options which are available. If you go to chamfer and select your edge, let us say multiple edges I have selected, and here you can go for the propagation tangency or minimal, and also you can go for the different combination like two length 1 is 10 and length 2 is 15. I can see the preview here, or I can flip that, reverse this, and symmetric extent is used for positioning symmetrically, so but it is not relevant here. Now we can see the preview this. Now what you need to do is you need to understand the chord length and angle. So what is the chord length? You need to give this tangential distance. Maybe I'm interested to have 20 with 45 and see the preview. So this will be 20, this. And final one is height and angle, and whatever the height, only the height protocol. So you'll drop from the vertical the distance. I will show you what height means here. So this is the height. So to this diagonal, you can drop and you can measure this height. So this kind of typical parameters if you need for complex application, then you can choose this one, height and angle. So whatever the height you need, and so let us say my height is 19. So this will be 19, and accordingly the distance and all will be set. So please understand this concept very carefully. Next we'll be looking at the draft, and draft is one of the important engineering application, or you can say dress up feature, which you apply for facilitating manufacturing operations, for e.g. withdrawal or e.g. ejection, etc. So by looking at this example, what you need to do is for defining your draft, you need which phase you need to draft, apply the draft, and the phase which you select for referring the draft angle, or you can say the neutral plane. So let us look at this example 6-55. This is the final output. This is the output, and let us look at this example model. Okay, so where do you get the draft? If you hover the cursor here, the draft angle, and if you move inside, you have like draft reflect line and variable draft angle also. So if you go to draft angle, here what you see is phase to draft, whatever the phases I need to draft, and whatever the angle of draft you need to assign, and the neutral element. So this top face is my neutral element, and this is the angle which you can see here, and maybe 15 I'll be okay. Here 15 will be updated, and go to preview, and here you can see the output of the draft, and just go to OK and look at the draft. From the top view you can see the draft, and this is the draft applied to that particular selected faces. Now we'll explore the advanced options here. Instead of your face as the neutral plane, you can select your datums or these planes and also can do the same operations. And resulted draft will be also can be found in same way. For example, I'll just select and delete that draft so that I could show you how to create that reference plane concept. And here are the reference planes. So what we need to do is I can create a reference plane. Maybe from the top, I'll go to the front view and I'll be okay with dot plane somewhere here, -25. Okay, go to the isometric view and do the same operations like the faces to draft. These are the faces, and the neutral plane is not top plane but my angle. And here are the dimensions which you need to attach. Preview and go to OK. And now you can see this is what is the output. And if you double click this, you have the reference where you can switch the directions and see the preview. And draft will be like this also. Draft angle can be flipped towards downward or towards upward, and you can also control. So the draft you could refer one neutral plane, and which could be your datum, which could be the plane which you have defined. So this is one aspect which we understood here. Next will be the parting, where we'll be looking like the two different sides we need to process at two different, you know, the drafting values and how to do that, and face drafted with the draft both side, and the face drafted with the parting equal to neutral. So parting neutral and these options how to use, that we'll be looking into. Next we'll be looking the advanced other operations like the reference. Let me delete this. And when you select this particular draft, and for understanding this example, we could take the example this one, and another example is here where we have drafted the both. If you try to understand this, what is the one changes which you have done, that you need to see this here. Here you have that parting equal to neutral and parting both side. This is the option, and the rest of all options are same. Two element this side we have selected, and the plane which you can select your reference plane, whatever you have done, and here is the parting equal to neutral. How do you do that? Let us look at this example. Okay, go to the draft and select the draft sides, and you could select all the four also for drafting. All the four side I want to process, and now the neutral element is this. And now if you expand this here, the parting equal to neutral, and if you see the preview, so resulting body definition exceeds model size. Okay, so 15 degree, I'll go for 5 degree. Still having issues. Okay, pull directions, you could select this top plane. Neutral means it will divide automatically your this one. Four elements. Okay, let me fix this. So what you can do here is directly when you select this particular option, like these are the faces I need to draft, or maybe all the surfaces, and this is my neutral plane which I was discussing, and this is the direction, and controlled by reference. This pull direction, if you switch off, automatically the pull direction will be guided towards this. And if you go to the parting neutral, what happens is this type of dilemmas you may encounter. Just you can switch off the directions and you can fix it. And this particular plane, you could directly recheck it is perfect or not, and it has to come here. This is the output. Now if you double click this and go to draft both side, so just ignore this and go for OK, and both side will be drafted. And here you can have maybe 20, and in preview it is just generating error, but in fact it will be created. So just I will ignore that, and this is the draft applied by using that. Let me show you this example which we have taken here. So here the plane selected is XY. If you right click it, you will get the XY YG GX. So XY is nothing but this selected plane. So that we can select from here XY, and the pulling direction is not there. And here you can have the variable draft that will look later, and parting equal to neutral. With respect to this parting line, one portion will be not applied and another person will be applied, and that you can see the pull direction. If you switch up at, this will be the output, and if you reverse this, this will be the output. So here you can have the flipping and whatever the angle you need to specify, and faces to draft you could add more faces as well. It's no problem at all. So because of that, it is getting, just you ignore this, you will be getting the final output like this. Now in this particular reference, what we are trying to get is with respect to a particular face, let us say this faces we are going to select, and plane to be selected as the neutral plane. It is at the, you know, uh, somewhere down, and plane to be selected as the parting element. So this particular plane will be used as a parting, so that you can apply your concept here. So I'll show you so that you can understand this. This is the example, and what we are trying to establish here is define the parting element. And let me show you all planes which are available in your model. These are the planes. Anything particular geometric plane, this also will be using it. So if you see from the front view, you could able to see exactly wherever we have done the parting there, this reference line, that is the plane we have established with respect to the atom plane, or from the top surface also. It is at a gap of 20. So this 20 we need to use for the parting. Now what is happening here is, when you select what are the faces you need to draft, next what you need to do is you need to specify your angle. And the neutral plane is nothing but the plane which we are using for giving the direction protocol. So of course it will be the top faces or anything related to top. So that is XY. So if you right click here within this option, you can choose the bunch of existing plane XY, YZ and ZX. We are interested to have XY. So you can choose XY. And now the parting plane is nothing but the plane which we have selected here. And once you select this particular plane and define these parting options, if you only click only, these options will be highlighted, else you won't get. And now you can see the typical parting done through that particular face, and it is established. So what is done here is very important. So dart form is cone, or dart form could be square. Here you can see the conical or squarish that you can define. This is the advanced options which you can refer, and you may be wondering, if you go to this measure between this point to this point, this is something, so it will be choosing it, so we don't control it. So directly based on these selections, it will be controlling that. And if you go for this to this distance, the same is maintained. So throughout these operations anywhere, it do not see any direction or control for your distance. So what you do is this particular parting surface, when you select, that will be guided. So later on you can trim and get the final dimensions if you require. So this is the two-stage drafting directly by referring a parting surface. Next is what you can do is you can limit between the selected planes, and the resulting draft will look something like this. So you'll be applying draft to these faces by limiting in between, so you can remove the material there. Let us look at this particular example. This is the example and this is the final output. So what is done here is nothing but, if you look at this particular draft here, whatever the draft angle you have given and the direction, it is away. And here look at some of the directions. If you go to the neutral element, this particular face is selected, neutral element, and pull direction is decided accordingly. And here, based on my selections, this limiting planes, this plane. So if you select away or if you select this way, just like the before example, the output will be different. So without worrying, you can control the directions, select the planes. Here you can see the planes also. These are the planes. And when you select this plane, just you create the planes by referring these faces and offset it and position it. And here you can see the particular output by selecting. So you have to select this face as the draft, this red highlighted, this one, and neutral face is this top highlighted one that we have to select. And rest of all, you no need to do any alteration. You have to select the limiting planes, and finally is done. This is one of the advanced options which you can find only in CATIA. Next is adding drafts using the reflect line. So how to use that? So face to be drafted and draft using the reflect line concept is very advanced and new concept, but try to understand that in virtually by referring the planes itself, you can create the reflective draft concept. So let me show you by using this model. This is the example and this is the output. So if you refer first the raw model, and if you go to this draft reflect line, and face to draft is this, and if you see the particular selection, and if you go to more, here you can see the limiting element, and if you select this, you can see the preview. And if you do not select this and go to clear selection, now if you see the preview, still it does the work. And you can see the pulling directions for giving the output. It is not valid if you give these as the pulling directions and see the preview in this direction. If you give this as the pulling direction, it will be done in that, and so on. So pulling directions you could select, and you can use the parting surface also where you want to part. Let us look at the final output of this example. This one, 68. Here you could able to see all the selections also. This is the draft. What is done here is all the faces we have selected, and now the XY plane we have to pick. Rest of all are the same, and you will be getting the final output. Next we'll be looking at the variable angle draft and its corresponding configuration. In our coming session we'll be discussing this as well.